scholars. In our last video, we got to this point. We were talking about different types of mutations. We mentioned these are all point mutations, that's substitutions, which just switches one letter out for another, but deletions, which removes the letter, and talk about insertions that add in letters. A couple other terms you might need to be familiar with in regards to this is the idea of an insertion, and deletions and substitutions. They can all result in a protein that is different than the original protein. If you get a protein that is different than the original protein, another descriptor for that, the type of mutation we call it, would be a missense mutation. Missense results in a different protein. That's what we've seen so far, is a bunch of missense mutations. That's a little different than a slightly different type of mutation. Every one of these is resulted still in a protein, still with 4 amino acids, just different amino acids have been inserted in there. What if you had, from this, you had this mutation take place? What if we had, instead of a C right here, we had, an A, so let's change both of these to this, ACT. That would mean that this, that's a U, this is a G, that's an A. UGA, if you're looking at your genetic code, is actually a stop codon. That ends the process. It's over right there. This protein is shorter now, thanks to the mutation. Missense mutations result in basically the same length proteins, just different components. Nonsense mutations is one that gets stopped early. So missense is this, that's a little different than nonsense. Nonsense stops early. And guys, remember, whenever you're transcribing and translating, nonsense mutations always, let me rephrase that. Every time you're transcribing and translating, whenever you hit a stop codon, the process is over. It's done. It's going on. Like this is stopped and there's still more going on, it's over. One little change can result in that. These are all point mutations. Take place in one point in the genetic code. That's all been in the point mutation category. There's another bigger category of mutation besides point mutations. This is what we call chromosomal mutations. Chromosomal mutations. So let me write that up here for us. Chromosomal mutations. Chromosomal mutation. In a chromosome, remember, it looks something like this, going on like that. We talked about that a lot. What a chromosomal mutation is a change that happens in a much bigger scale than just at one location in the genetic code. No, this is going to be a big piece. Maybe we had a piece that gets lopped off. It's cut off. If it got cut off early, well, we know what that is. That is a deletion. If, let's say you had an original chromosome that's sitting there, and we ended up doing this and inserting a segment into it, that would be just what it sounds like. That would be an insertion. You could have an addition. It sounds very similar to an insertion, except for an addition would look like this. You have your original chromosome up here. In an addition, you could just add on, make it longer. So we add it on. That's an addition. So these are on the big scale. This is hundreds of nucleotides long. Huge pieces that are reconnected, disconnected, reconnected, maybe in the wrong spots. Excuse me. Other examples. These are pretty common sense. Deletions take things out. Additions add on. Insertions add things in the middle of things. Two other types of chromosomal mutations that are significant are these. We can have what we call a translocation. Let me show you what that looks like. In a translocation, what you have is a chromosome, two chromosomes. Well, let me make them different colors to really drive home what I'm talking about. So let's make one black and one blue. Okay. In a translocation, what has happened is perhaps one segment on one side gets swapped with the other side. Like for instance, something like this takes place. You say, Mr. Wells, that sounds just like what happens at a crossing over. Yes, that's intentional. That happens in the meiotic process to create new organisms. By and large, though, outside of meiosis, we don't want much change happening. It's going to. We try to keep it to a minimum, so that safeguards against that. If we swap off pieces like this in just the mitotic process or just in cells doing their everyday lives, this is a translocation. So we call this a translocation when chromosomes swap different parts. So that's a translocation. Bigger segments that have just been switched between chromosomes. The last one we like to bring up is one we've mentioned in passing before. We call it a non-disjunction. Remember, guys, when we have, let's say, metaphase 1 of meiosis, you have 4 chromosomes here together, the tetrad as it's called. Now, ideally, these should separate somewhere along here and go their separate ways. Non-disjunction is a disorder that instead of splitting there, maybe it splits here. Maybe it splits here. Splits in different locations. We have, instead of going 2 and 2, maybe it's 3 and 1. Maybe it's even out here. Maybe it never splits at all. It's 4 and none, resulting in extra chromosomes in a cell. This process results in a number of disorders, the most well-known one being Down syndrome. This is not an inherited thing. This just happens. It seems to happen more as you get older, it appears, or as people get older. So non-disjunction happens. It's a meiotic thing, but that is a mutation wherein the chromosomes do not separate properly during the anaphase step of meiosis. So that is, I'll put that word up here for us. This right here is non-disjunction. Now it occurs to me now that I write this, you may not be able to read that because it's such a dark, or superficial light color. How about this? Let me write it darker. Non-disjunction. So this is non-disjunction. These are different types of mutations that take place. Guys, mutation is the engine of change. All the changes in the genetic code come via mutation. Every single one of these. Some are good, some are bad. Most end up being more detrimental than not. But nonetheless, they're out there. I leave you with one final thought. What if you had a mutation that had no effect? Remember back here when we first saw a genetic code? Let's say I had this. Let's make it really short. THC, CGC, TTA. Okay? So if I have this as my genetic code, or my DNA rather, the RNA would be, different color here for us, UAGCGAAU. Now, if you look at your genetic code, we can see what the exact things these code up for. Let me grab mine real quick. The genetic code, recall, ties together each codon with a specific amino acid out there in the proteome. So, let's say UAG, we know this one, right here. UAG. UAG on here. says that, finding my list here, sorry ladies and gentlemen, UA Health, it's a stop codon. My mistake. If this was a mutation, by the way, this would be a nonsense mutation. It would go nowhere. I messed up. Let me give you an example that would actually go somewhere. If instead I had this, let me change this to here. Let me do this. Let's start with the start codon. That's what I meant to do, and I typed the wrong one up here. Okay, there. Sorry, made a mistake. Here's a better example. You have this going on. AUG is methionine. GCG, based on this chart, is going to be alanine. And AAU, outside of the Amateur Athletic Union, is asparagine. Now watch this. What if we had this mutation happen? What if instead of there being in the second amino acid, the second codon, instead of there being an C right here, what if there was a T? This change right here. That would mean that this has to be an A. GCA on the same chart tells us is also alanine. This change did not affect the actual protein. The mutation, it's almost as if it had no effect. It's almost as if it were silent. The final thing I'm leaving you with is the idea that mutations can be silent. They can have a point where there's a change, but if it doesn't actually affect the protein, we call it a silent mutation. Silent mutation. That is the big picture of how mutations work. There's lots of different ones, different categories and ways of describing them, but I try to give you every one that we're going to deal with, and all the big ones essentially in our class here. This video is going to be useful in preparation for the assignment you're going to have on Tuesday and in class when this up. Thursday, don't forget, we'll be going to lab, working with Ms. Hendricks on bacterial transformation. If you want to look, I'm going to send you a message on Canvas, obviously if you haven't stumbled on this yet, to watch these before you get to class, because you won't necessarily be able to see them in class. Nonetheless, I hope this has been helpful. Hope you do all the assignments. Hope to see you again soon.